Good evening, students. This is Mr. Sugai. We're on page 28. Now, I actually went through the workbook and did a video, but somehow it got lost in YouTube, you know, um, cloud or something like that. So I'm going to just review what I did go through. And this was page 28 of book 2. This is Halloween evening. So this is the page that I was doing first. It did not go up correctly, and I did another YouTube video tonight that completes this video. But just let me go over one more time what I intended to upload, but it didn't go through. So here it is. I'm just going to give you a brief rundown. On page 28, we have two charts, graphs here. F of x, g of x. Now under A, it's asking at x equals 1, which is right there, x equals 1, is g of x or f of x greater? I can see that f of x, which is this one here, it would meet x1 at about this point here. So this point is almost 4, and this point is negative 0.25 or something like that. So I would say f of x when x is 1 is going to be greater. Okay, right there. Now another question, for which value of x is it true that f of x equals g of x? Now the key word is equals. These are two lines intersecting only at one point, and that point is right there. The x value for this point is 3. So f of x and g of x shares that single point. When f of x equals g of x, it's at x equals 3. Okay, you can see that. Now going on to C, it's asking for which values of x is it true that g of x is greater than f of x? What values of x is it true that g of x is greater than f of x? So I can see that anything greater than 3 would fulfill that requirement, because g of x is greater than f of x from here on. So it's 3 on all the way forever. Okay, and it's described like this in this number line: from 3, but not including 3, all values of x that's greater than 3. So we color that in right there. Now for C here, they want you to do it in set notation. So it's written like this: all values of x such that x is greater than 3. Okay, I hope everybody understands that. So we'll be moving on to the next page. It's a warm-up. It's pretty basic stuff, but we'll go through it anyway. It's just a warm-up. Solve each equation. Show how you determine your solution. Okay. So in this case, I just distributed the 3. 3 times 2x equals 6x. 3 times negative 5 is negative 15. Then I bring down the 55 minus 4x. Now I'm combining like terms. I see the x is there. I'm going to bring that 4x over here. So I'll add 4x to both sides. That'll give us 10x minus 15. Bring down the 55. Now our next step, I'm going to add 15 to both sides. So that negative 15 goes away. I'm left with 10x on this side of the equal sign. 15 plus 55 is 70. Then I divide x, divide by 10 to both sides. I'm left with x equals 7. Okay, the next one. Okay, again, we have to use distributive property, so I can work with the like terms here, the x terms. Bring down the 13x. Negative 2 times 4x equals negative 8x. Negative 2 times negative 7 is positive 14 equals 9. Okay. So the 13x minus 8x, I'm left with 5x plus 14 equals 9. I have the 5x here. I minus 14 to both sides of the equation. That's going to make that 0, which is exactly what we want to do. So, okay, we have 9 minus 14, so that difference is negative 5. Divide 5 to both sides. I'm left with negative 1 over here. Now I'm going to do that other problem here too. That's the only one that I wanted you guys to do on your own, but since I'm doing this video again, I'll do it again, okay? I'll do it. Okay, combine like terms. I have a 9x minus x, so I'll call it 8x. Minus 5 plus 2, I'll call it minus 3. Equals, I'll do distributive property. 4 times 1, 4. 4 times 2x, 8x. Ah, that's weird. So I got an 8x here and an 8x here. So this is not an equality, because I'm going to be left with negative 3 equals negative 4. It's not an equality. Can't be done. Okay? It's one of those special situations, I think. Just let me double check. 9x minus x is going to give us 8x. And over here is 4 times 2x equals 8x. So yeah, that's a bad problem actually. I'm not sure why they try to do that sometimes, but they do. That's a bad problem. Anyway, from here on, page 29, go to the next video. Okay, this is page 29. As you can see, it's already filled in because I did a whole video on it. So go to the next video, page 29, and check out how we did it, okay? Until then, I'm going to sign out. See you tomorrow. Bye-bye.